Good evening, all.
Good evening.
Hello.
Hello. Okay, I can get behind that. I am Mog.
Hi, Mog.
Hi.
Teal.
I can't read your badge from this far back.
Teal, the tool man.
Teal, the tool man.
Hey, Mog, how are you?
Hi, resident attendant. I'm here to.
Oh, I'm the speaker at Freaknik now. I'm better than you.
I'm not better than you. I'm better than him. It's different.
All right, deal.
Okay, so I'm here today to talk about clustering, in particularly on Raspberry Pis. And Ben gave this wonderful title because I gave no title. I was like, title to come later. And so that's why it's dictated but not read. I feel like Ben reached into my inner soul and pulled an amazing title out. So I'm very happy.
Did you wash afterwards?
I hope he didn't.
Doesn't dictated but not read mean you said it, but you didn't read it? So like, what that first slide there.
Right.
Can you go back?
Okay, go back.
Yeah.
Okay.
Yeah, so that right there,
Which part?
the bottom part, the one where it says dictated
Where it says
but
by
not
Mog?
read. No, the one.
No, that means it was like I wrote it. It's
Yeah.
like my thing. I'm claiming ownership.
Yeah, but you're a liar.
Right.
Okay.
But I thought that was known quantity, right? Everybody knows that I am a liar here. My name's Mog, and I'm a liar. And it's been
It's Ben.
6 minutes since my last line. So I'm hoping to make it through the rest of the speech sober, or without lying. So this is me. You can reach me at GitHub or on Twitter or email, and all the chat stuff is awful and horrible.
What
And
about
so,
BitMessage?
BitMessage is dead. So I gave a talk here like 3 years ago about BitMessage. BitMessage was like the savior. What's the the line from Batman? He's like the hero we deserve, but not the hero we need, not the one we deserve. So BitMessage was the hero we needed. We didn't deserve it. It's dead project.
Real quick.
Yes.
In those movies, he said he didn't use guns. At the very end, he used a gun to shoot the driver of the truck. So he is also a liar.
We should use a gun.
On his motorcycle.
His motorcycle? That wasn't a gun. That was a love pillow.
He's sleeping.
It was a rubber bullet, yeah. And it wasn't even a rubber bullet, it was like a beanbag. Would you say if I don't have a beanbag here, if I grab...
What's on the next slide?
What's on the next slide? Excellent question here. The next slide. Clustering! What we came to talk about.
That's a nice CRT monitor.
Does anybody know what this is?
No.
It's a Minecraft. The
Projection screen.
Is it a cluster?
It's the first result on Google image search if you search the word cluster. Fabulous. So yeah, clustering is gathering up computation resources to solve problems together, and it's fabulous. And this is several computers. Diggy, hit me. No, you can't. You can't back out. You gotta commit.
Well, no, I'm sorry. Okay. I'm sorry.
Because you're slowing it down for everyone.
No,
Can you share with the rest of the class?
I just wanted to point out that we just Googled it and you're lying again. I'm sorry. Go ahead. Continue.
Come on, man. You know that SETI at home.
I'm sorry, but I'm sorry. He's a liar. Sorry. No, go. We're going to leave you in. Turn around. Please, lie some more. Go. Sorry.
Moving on. This is a Raspberry Pi 3. It's a thing.
Is it like a green pie?
It is in three ways like a cream pie, but I will not go in deeper to that situation. So a Raspberry Pi is just an ARM computer. I'm sure everybody here knows what they are. This is a Raspberry Pi Zero. It is also a thing. It's only like a cream pie in two ways. I'm gonna leave you to flip back and forth, try to figure out what's the way that's missing. I'm sure
It's
the
big
brightest
and wet.
among you will get it.
Big and wet.
And so you put them together and you get a cluster fuck of pies.
Hell yeah.
So this is a piece of hardware called a cluster hat. It is just a USB hub that is controllable over I2C and allows you to have 4 Raspberry Pi Zeros controlled and powered by a Raspberry Pi 3 host. It's nothing too magic. It has some pretty LEDs, and that's about it. It has an EEPROM to like remember some settings you do, but it's nothing magic in itself. So the software itself, like I was saying before, it's an I2C controller that can turn the hub on and off, so you can like cut off all communication to the other Raspberry Pis, as well as turn them on and off by control.
Array start at 0, not 1.
So that is a patch that should be sent to the developer of that project, because I shared this same outrage, because all of his configs start at 1, and they are ridiculous.
You must come from Windows.
Including his silk screens. The silk screens on the board, it's P1, P2, and P3, and P4. It's outrageous that he did something so awesome and doesn't know how to count. I think it shows that you, someone that does know how to count, what are you doing with your life? Why aren't you making
Nothing
awesome
right
pieces
now,
of hardware?
nothing at all.
Okay, so moving on. I guess the goal of what I was doing was I wanted to create. Oh my gosh, I got props. So mine, I didn't bring mine with me because mine's actually in use right now. So why I wanted this in the first place is I have I work where I work with multiple teams, and I have to have software that I build for. I work on the platform team, and so I support all the other teams that do front-end work and mobile work and GDPR work and other kinds of work. And so I support these different teams, and I spin up software that has to remain while they build their other side of the software. And so I needed a way that I could have multiple versions of our API running continuously and not have to deal with anything. And given that there's no user load, these actually function very well on the Pis. And so I have something just like Not Larry, my lovely Vanna White gave me, right here at my desk at work. And so that's what I use. That's why I did this project. The other reason why is my company is moving over to Kubernetes, and so I figured good time to learn Kubernetes because this is really cheap. So that each of the Pi Zeros, are like $5 or $10 if you're getting screwed over by Amazon. The SD cards are very cheap. The Pi cluster hat board is like I want to say it's like $30 by itself. It's not very expensive, and then the Pi 3 that you'd run this on is also only like $20 in that ballpark. So you can build your own cluster for about $200, and it's really useful. So once you have all the hardware, the next part is setting up all the software on it and getting it going. And so that's what this in particular is. The first step is you install Raspbian on all 5 computers. What's special is, or what's really cool about this project is the Raspberry Pis all have the ability for this special Linux kernel mode called USB Gadget Mode. And what USB Gadget Mode allows you to do is have the USB port that this is plugged into is providing power. It's also creating a serial interface to the device as well as an Ethernet interface to the device. And so I can now, with this magic line on each of these Pi Zeros, I can serial into the Pi, I can connect it to an Ethernet network, and I can power it. So just connect it to this with a good power supply, because each of these Pi Zeros take like 400 milliamps doing nothing. And so you need a good bit of power. They recommend like a 3 amp power supply connected to it. But you have all those, and so then you can have 5 or 4 Pis talking over Ethernet to your one host Pi. And so once you get all that set up, and that's, like I was saying, that's all that this line is. It's defining a MAC address so that you can know which Pi is which, because like I was saying before, you can turn on and off the first Pi, the second Pi, the third Pi, the fourth Pi, or the 0th Pi, the second Pi, the first Pi, and the third Pi, if you're crazy. So you can do that, and you can also address them over Ethernet that same way, and it's just easier to know what you're talking to. I don't think that was God. I'm not positive, but He missed. Who's he gunning for?
Small.
Is it that guy? I think it is. Are you in or out? I think you should be in. This is the place to be. Okay, so moving on. So like I was.
Sorry.
Auto what? Auto Bro. So this is the Auto Bro interface. So this is the networking side on the host. So this was on the client side. You basically set this up, and you can use DHCP or static IPs on the client side, expecting it on the host side. And on the host side, you set up a automatic bridge interface with no devices connected to it, because you don't know if the Pi zeros are on or off, and so you don't want to have like the bridge interface hanging up because the devices aren't there. And so you create just a very simple bridge, and then the so the ETH Pis, I have a UDEV rule that is setting up so each of those USB Ethernet devices that are now being connected to the Raspberry Pi base through the hub, they create this device that I'm setting up to do a manual networking interface onto the Pis. And so right now, like with these two things set up, I have the Pi host with a bridge, so like a switched interface to the 4 Raspberry Pi Zeros that are sitting on top. So like at this point, you could like SSH in to each one of the individual Pi Zeros and do work, coordination. And this is actually like all I needed for like my job. Like I got to the point where I had all the Pi Zeros doing the individual workloads that were needed for people, and this is like the baseline of what I needed. And this was easy to set up within a day. It's very useful. But can't stop there. There's much cooler coordination and configuration support for controlling your environment. And so there's a clustering piece of software called Kubernetes that I am like 30% sure is spelled correctly up there right now. So Kubernetes is a tool that you use to define, control, administrate your cluster. And it is incredibly portable and runs pretty well on the Pis. On the host, it basically takes up like all the CPU load. It's like 1.5 top to just run it. So you're basically doing nothing on the main board except managing the other nodes. And so first thing you're going to need to install it. So this is kind of like the steps that you'll need to run on each Pi to get the Kubernetes tools installed. Kubernetes themselves package a version that they've compiled for ARM that runs on the Pi is great. For some reason they package against Ubuntu, but it doesn't matter. It works fine on the Raspbian with this stuff.
It clearly spells it correctly in your commands, is all we're pointing out.
Oh, it was correct?
No, you're wrong. But it's right in your commands. I'm just saying that it was a very low effort to actually correct it.
Kubernetes.
Yeah, go ahead, sorry. You keep looking
do I
at
need
it.
like 8 more E's? Like where?
Kubernetes.
Less
Okay.
E's.
Less
You
E's.
Englished it.
Okay. So
It's got an L instead of an L.
it's got an L?
Yeah, it's Kubernetes.
Coolette.
Hey, go back.
Go back?
Yeah, it's right there.
Oh, no.
So there you go.
Oh, there's no
Yeah.
between the R and the N. It's not Ren. Kubernetes.
Yeah, it's there 3 times. I don't know if you noticed.
3 times.
Yeah, I mean,
I feel like you need a laser pointer.
yeah.
And you'd be
Me
like,
too. I was just trying to-
dangerous.
oh, you're just trying at me?
Okay, go ahead.
Okay.
Go.
Anyways,
be dangerous for him.
so the main outline. So you can imagine this top piece is like the master. This is what the Raspberry Pi, the main Raspberry Pi 3 will be running. It's running some configuration, scheduling, as well as the Kubernetes API server that you're going to be talking to and administering from your own box, separate from everything. And then below it, you have this concept of like pods, where each of these nodes is a pod, and a pod contains the Kubernetes. It's called a kubelet. It's like the little bit of infrastructure that kind of controls the individual piece. You have a networking controller that controls, like I was saying before, like how it's networked into the whole cluster. You have the container runtime, which will be like a Docker image, that is running the application that you're going to be running, and then you have like the bare bones OS. In this case, it'll be like Raspbian for each of the 4 nodes there. And then this is kind of showing you like the diagram of like how each of these different pieces is talking to each other like protocol wise, and like what objects are being passed over the wire and how it's set up. But it's not, like I said, it's not very important to getting your first thing going. You don't need to completely understand that. And so the first thing you're going to do is configure the host so that you can then add the, so once we've, like before, we had installed the Kubernetes software on all 5 machines. And so now on the host, which will be the Raspberry Pi 3, we run the kubeedit administration tool to init the pod network. And so it runs, and then it gives a token that you will then basically run on all the clients to connect everything up. So so you run this. It takes about 5 minutes, I think, on the Raspberry Pi, because Raspberry Pis are a little bit slow. And it comes back with this token that you can then run this command on your clients. So you basically just run that command. They join up to the network, and everything is great. It's ready to roll out some software onto the pods. Or actually, sorry, there's one other step. There's a networking piece of software called Flannel that everybody seems to recommend using to help deal with networking the pods into the host, into its like a kind of its own separate networking space, and it handles everything for you. And it's a pretty cool piece of software. You just basically tell it that you're not running on AMD 64, that you're running on ARM, and you tell it to go. So once you have that set up, now you can verify that everything works. So you can see the kubectl git PO will show all the nodes in the namespace, and then git nodes will just verify all the nodes are up and running. And so you're now at the point where you have a operating cluster, and like I was saying before, you have the host chugging away like at 1 load, and then the clients now are chugging away at like 0.25. Like it's a little bit ridiculous, like in that there's so much overhead in running all of this. It makes a lot more sense to be running in the cloud on like real hardware, but it's really nice to be able to mirror that stuff on your desk. You're just not going to be able to push a whole lot of traffic because of the added complexity of all of this versus what I was saying before, like at the very beginning, like running it just networking everything together and not running any of this management software. So the next thing that we could do is we can deploy a Docker image to all four pods. And so what this is doing is it's running on the host this Docker image that it got from Docker Lab, and it's replicating it onto all 4 nodes, and it's saying to have port 80 as the port that it's going to be using. And so once you execute this on all the nodes, it's going, or on the master, it goes down, gets the Docker image, and then it passes it to all 4 of the nodes. The nodes spin up, and they get to the point where they're running this application, and you're ready to go. This get endpoints command like kind of will verify that everything's going, and then the exposed deployment will set it up so that it's actually exposed to the external network. So right now, you can only see those different pods from the internal network that we defined with Flannel. But once you expose it, it's now running in the real world, and you can use it. Yes?
What does this mean in layman's terms?
Which part?
All of it.
All of it. So the goal is to set up, so you have this hardware on your desk, and you want to be able to take the applications that you would normally deploy in the cloud and deploy them to this hardware on your desk. Because it is useful to know, or it's difficult as a developer to deploy code to the cloud because that costs money, and you're not going to get permissions to set up namespaces and everything else in the cloud. It's much easier to just replicate the work that you're already doing for production onto a local piece of hardware.
Oh, okay.
Is the goal. So like realistically, like I was saying before, if you don't have to do all of this, it doesn't make a lot of sense to do it. It makes a lot more sense to just set up a network for these 4 devices, and then you just run software on them directly. There's a whole lot of complexity and infrastructure in doing all of this, but it's the exact same infrastructure and complexity people are doing in production. And so if you can understand this and do this, when you actually do go to production, it's a lot easier to deal with because you've done it yourself. And you've done it in a completely safe space. Like if you screw this up, you can just flash all the pies again if you wanted and start over. It's not causing any problems. Yeah, Jeff?
Does that mean that Kubernetes is not Raspberry Pi specific, or it is Raspberry Pi specific?
No, it's not Raspberry Pi specific. It's most commonly run in AWS and Google Cloud Engine, I would say. It's very rarely run on Raspberry Pis. It's just a code that is portable, and so it can be run anywhere.
So Docker is per host, and Kubernetes allows you to control a whole data center of Docker.
Yeah, and so like once you've done this expose, you've gotten to the point where we were at the beginning of just running the application directly on one of the hosts. The advantage is that you've done it in the same Docker environment that you would have been doing in production, because ultimately everything ends up in production. So yeah, that's basically it. Are there any more questions or spiffy stuff people want to know about Kubernetes or anything? Yep.
Yeah. Can you give us a little bit more information on a namespace and how it applies to logical interfaces and logical storage?
No, right?
Not a lot. No.
He is about to make something up. Go.
No.
No, it's okay. We expect to go.
Yeah.
Look, you admitted it at the start. Go.
No, it works like namespacing. To my understanding, like I'm not an expert on this, but it works like namespacing anything. You build your environments, and you can separate them based on those namespaces. So you can build a networking namespace that is separating, just like how you separate VLANs.
So like a scoping mechanism.
Yeah.
It's a logical separation of a group of pods. Pods can have multiple containers. Groups of pods can have services exposed on the service layer and routed above, but then that is encapsulated by a namespace.
Right.
Exactly what I meant.
He was getting there.
What kind of workloads are you running?
So I was mostly doing. So the most intensive task that this work does is it signs a bunch of data. So like a few megabytes of data a second is the most intensive thing that was going on there. And then there were some very large Postgres table scans, but nothing intense is what I was doing on this device. But it was definitely effective at serving like 5 other developers that were developing on top of this service. So it was really useful for that. But I definitely wouldn't try to go to production with something like this. It's a horrible waste of effort.
So if you were to get a whole bunch of these little clusters together, how many do you think it would take to mine a Bitcoin a year?
So
Yeah, more than all of them. Yeah.
So there's a lot of problems. So the reason why I really like this piece of hardware is it allows you to have all these connections made in a really tight space, but it's also not a useful way to do it. So like it's using this USB mechanism to talk to the host underneath it, which means you're maxed out at USB 2 speeds of, what is it, 11? What's USB 2's max speed?
12.1.
12.1? Right, whereas you could be using Wi-Fi, or you could have a better connection other ways
So
to
10,000,
push the data.
100,000, a million
I'm going to say,
for 1 Bitcoin per
I'm
year.
going to say it would take 10. I'm not going to tell you the base though. But it's going to take 10 of them in a closet of indeterminate size to mine a Bitcoin.
How does this relate to Mesos? Is this built on that or around that?
So to my knowledge, I've not done any of the Mesos stuff connected to it. To my understanding, you can, but
virtualizing a machine inside of the.
So it's running Docker. So it's running Docker on these machines, and the code that's being built for it is ARM. So it's no emulation. It's
Right.
running it natively on the boxes.
Those are running Slurm on the bare hardware.
These?
Yeah, so you just schedule your job and it deploys it.
Mhm.
It does the deployment.
Yep.
So why not just emulate it on a better piece of hardware?
So one of the reasons why is a better piece of hardware costs money. This was very inexpensive. Like, so my tech budget is like $500 a year, and this was like $200, and I could just throw it on my desk, and it blinks in the corner of my desk and doesn't bother me.
It looks cool on the desk.
It does look pretty cool. People are fans. And the other reason I think is simplicity. I feel like there are people that have done this. Like if you go Google Raspberry Pi, Kubernetes, there are lots of people that have made these clusters. Whereas if you were doing this on real hardware, like a more beefy PC, you'd be virtualizing like all these pods and then doing this. It feels like a more bastard way to do it. Whereas this, although these machines are all super slow, I'm actually building up a real cluster, like, and connecting it all, and I can easily see things like one of the nice things that I've played with. I haven't done to any practicality, but like you can turn off one of these pieces of hardware, and the Kubernetes can detect that a pod was lost and spin up another pod, and so Kubernetes has a lot of tools about like managing workload and spinning up more machines and spinning down machines and detecting networking issues and other stuff. And it seems like this, I haven't done a lot of this yet, but it seems like a very good platform for being able to play with all that stuff really directly. And you're right, you could do it all in virtualization, but I just feel like it's a little bit disconnected from reality because it's virtualized, whereas this is real.
How fast does Kubernetes spin up a new pod? Is it able to actually
So
spin up fast
if
enough to pull off the RAM as it dies, or?
I don't think it's that fast, but it's when things die on this, like when I turned off a pod, it spin up the next pod within seconds.
Seconds, not
yeah.
milliseconds.
Yeah.
It's also that hardware though.
Right. It's also right. So like I was saying before, it's a USB bus. So not only is it limited to like the 12 megabits per second or whatever USB is, it's also shared across all of these. Like this is a USB hub.
Right.
Where these are all sharing that connected space. Strick?
Sorry if I missed it. Do you think a Pi Zero would have enough RAM to do this?
So this is a so a Pi Zero I don't think would have enough RAM to be the host for this. But the clients are all, the pods are Pi Zeros.
Oh, okay, cool.
Yeah, Joe?
And if you were to update code, is the idea that you would have these deployed and then push code to these, or you would push an entire new Docker image?
So the flow would be that you would build a new Docker image and then deploy the new Docker image out that way.
Okay.
Nathan?
Are you 6 feet tall?
Exactly.
Okay. Just making
Do you
sure.
have a measurer?
On your
to confirm
your
this?
Twitter, it just said there was information about your height.
It
so.
is.
Sorry, height.
It's accurate.
It's in doubt.
It's in doubt.
I mean, your record
Doesn't speak
suggests
well.
it's probably fabricated.
Wait, we're using Twitter for actual reality references?
Yeah, why do you like Twitter so much? Seeing as it's a dumpster fire.
It is a dumpster fire, but so like we can get into this. Who here likes any form of communication outside of email?
done?
What is wrong with you?
It's
I
all
like message boards. Leave me alone.
You still use email?
What's an email? Ouch. Email is like snail mail, but slightly faster.
Yeah, it's for the 90s.
What's a mail?
What's a mail?
Is it like a salad?
I think it'd be